So in this video, we're going to look at how can we measure the quality of our forecasting result in order to show the different kind of metric that we can measure the quality of our forecasting. And we are going to learn a very basic model called a naive forecasting model. So why we call it naive? Because it's so simple. Like maybe first grader will be able to know how to do this kind of forecasting, right? So just think about, if you have no information about the weather for today, how do you make a guess about the weather today? So when you wake up, you haven't gone outside the room, right? What you're gonna say is, oh, I think yesterday's weather is like 70 degrees, so I think today will be 70. So this kind of forecasting uses a last period value to assume the new day's value will be the same as last period. It's called a naive forecasting, right? So it's very simple. Like I said, even first graders sometimes were using that to do the forecasting. And my little girl who just woke up this morning, she was telling me, Mom, I think today's weather will be 70 and I will wear shorts. I said, why do you think so? She said, because yesterday was 70. So she actually was using the naive forecasting to do the forecast. So we are learning this model first, and then we're mainly focusing on after we get in the forecasting results, how do we know we did a good job to forecast my time series data? Okay, we began to develop a forecast for the gasoline time series, including the data file. And so in the lecture video, we are not showing the Excel part, and we will have the demonstration in the computer skill module to show you how you can use the Excel to do the forecasting, to calculating the metrics that measure the accuracy. Okay. And so we are using this method called the naive forecasting. And so if you look at the right-hand side, so the first two columns is my original data. So this is time series data, right? So because the value of the gasoline price, gasoline sales, 17,000 gallons, 21,000 gallons. So those are mapped to each week, right? So there is a relationship between my time and my time series. So this is my time series. So you want to do the forecasting using the naive method. So you basically, at the forecasting column, you are standing at week 2, and you try to guess what is the sale for week 2. So the information you use is using the prior week. Okay, so therefore I put down 17. And then in the week 3, I'm using week 2's value, so 21, etc. Okay, as you notice that in the original value, we have 12 observations. In the forecasted value, we only have 11. Because for the first period, the week 1, we had nothing to use to help us to do forecast, right? We don't have week 0's sales. So therefore, the first one is blank. So we actually give this how many period that you cannot use naive forecast to do the forecasting. We call it K, okay? So the K here equal to 1. So the K equal to 1. So that is how many period you cannot predict using the naive forecast. So naive only use 1 period in advance, so therefore K equal to 1. And so to measure how well my forecast column, in terms of to forecasting my actual time series data, we're using the different kind of metrics to measure the accuracy. Okay, measure the accuracy. So that's most of forecasting. Actually, if you have opportunity to get into the data science space, so we will do a lot of forecasting. The accuracy is the one we really care if you are trying to think about forecasting, right? And so regardless is time series data or you are using machine learning model, so accuracy is one of very important criteria you need to measure. So how can we measure accuracy? So in order to measure the accuracy, we need to introducing a new term called the forecast error. So if you recall, in the regression model, we learned a term called residual or error. So basically, residual error, it is measure the difference between the actual value and the predicted value. It makes sense, right? You basically, when you look at how accurate your forecasting is look like, you are trying to see how difference between your actual value and predicted value. So the difference between the actual value of your time series and that predicted value, that give us the value called the forecast error. So the first metric we're learning here to measure accuracy called the mean forecast error. So what we did is we basically find the difference between the forecast value and actual value, and then after we have all of them and sum all the error together, and then divided by the number of the time series observation minus the period that is missing from the forecast. So that will give us mean forecast error. Okay, let's look at the right hand side. This is the example. So as we use the naive method, so for the week 2, our forecasting is 17 and my actual is 21. And then the forecast error give us 21 minus 17, we got 4. And for the third week, we get 19 as actual value, 21 as forecast value, 19 minus 21, we got -2. So basically the fourth column here is the value for the forecast error. In order to get the mean forecast error, we need to first of all sum all those errors together, right? So that gives us the value of 5. And then we were divided by 12 minus 1. Some students might say, why 12 minus 1? Because first of all, we have 12 observations for my time series data, but we try to find the average forecast errors. So we cannot divide by 12 because for the forecast, we are missing 1, right? Remember the k equal to 1. So therefore, we use 12 minus 1. So in another way, if you just finding the average of this forecast error here, you will getting 0.45 as well. Okay, and again, we will show how to use Excel to do the calculation in the computer skill module, so you will learn more in terms of how to use Excel to calculate the MFE. So now you might gonna ask Dr. J, said, oh wait, 0.45 is not too bad, but then the problem here is that as you can see that if the sign, the 4 minus 2 give you 2, and then how about all your forecast errors -4, and then 4, -4, and 4. As you can see, you will have the arrows, but if you sum all the positive and negative value together, you might cancel to each other, and your mean forecast error becomes 0. It doesn't mean you'll get perfect forecasting. It is just because the negative and the positive sign cancel each other. So this makes you thinking maybe mean forecast error is not the best way to measure the accuracy, although it's very simple. So the reason is that you don't want the negative and positive error cancel each other to help you to make you feel your model actually predicting very well, right? So therefore, that's what we said. MFE larger than 0, this forecast method is under forecasting. And so we actually, usually in my real world experience, I never use the MFE because the weakness I just talked about. You don't want the negative and the positive sign cancel each other, make you feel your forecast model actually working really well. So now the question is, how can we fix this metrics? So that's the second metric I want to introduce, called mean absolute error, also called the MAE, or sometimes it also called MAD, MAD. So this is a measure of the forecasting accuracy that average the absolute value of the forecast errors. Remember, as I mentioned, we don't want the positive and negative error to cancel each other, and then so that we are give us false impression to think our model actually predicting very well. So to avoiding that, we are adding an extra step before we getting the average value, right? So first of all, we're still getting our forecasting error column. However, instead of just adding all of them together, we're actually finding the absolute value first. So 4 become 4, -2 become 2, 4 and 4. So to assure all my errors are positive before we're taking the average. So after we convert all the error term to the positive value, and then we adding all of them together, we will get 41. So the average of my absolute value forecast error will be equal to 41 divided by 11. Remember, we only have 11 value here, so it will give us 3.73. Okay, so these are actually relatively more accurate than the mean forecast error. Again, MFE, I really don't see anybody using it. So the MAT or MAE are popularly used in the data science community, right? Because it gives us a clear picture about, okay, what exactly the imperfect prediction we have, right? So this is I should say this should be our first metric. You should fully understand and know how to do it. So in the computer skill, I will show you how can we use the Excel to do the calculation for MAE or MAD. So the next metric we can use to measure the accuracy is called mean square error. So mean square error. So the same idea, we don't want a positive and negative sign cancel each other, right? So the other way to do it, instead of taking the absolute value, we can square our errors. So for instance, 4 square equal to 16, and then 2 square equal to 4, 4 square equal to 16, etc. Okay, so this method is called mean square error. And so after we taking the square and then we finding the average value for all my squared forecast error. So that is called MSE. So this method is very, very popular use in the data science world for any forecasting task, MSE. So when you look at MSE, it can only be positive, similarly to MAD, right? So it has to be positive value. And then the larger the value, the worse performance of your model, because it's just telling you that your forecast is way off from your actual value, right? And then so the problem for the MSE compared with the MAE is that the MSE are sort of a little bit exaggerating your inaccuracy, right? Because you square the actual value. So as you can see, all the time series value for the sales is between 16 to 23. But when you measure the MSE, that actually give you 16. So you are like, wait, it's kind of large errors, because the smallest value is 16, the largest value is 22, but my prediction, my error is on average 16.27. So you have to keep in mind that this value actually is doubled, or not doubled, the exponential by 2, right? Take exponential by 2. So this value is not measured at the same scale as your original time series value. So one thing you just know, when you compare different forecasting model, so the larger, the worse. So you can know that. But in terms of how bad it is, it's hard to see use MSE because you squared the error term is not measured at the same unit as your original time series data. So now, how can we fix it? Right? So you can take a part square root. So that's another way. But here I want to also introducing another method. It's called the mean absolute percentage error. So why this? So usually I use this one more often because this allow you to even compare across different kind of time series data. What happened here is after you getting your forecast error, as we talked about, we don't want to add them together. So we adding the actual steps. So first of all, we are using the forecast error, okay, divided by my actual value. So the forecast error divided by actual value. So for instance, and then times 100, and then take absolute value. So basically what happened for my first week or two is that I'm using 4 divided by 21 times 100. That's how I get a 19.05. Okay, and then similarly, I use 2 divided by 19 for week 3, and then times 100 and take absolute value, I will get 10.53. And then we can do the rest of the 11 weeks. So after I figure out the column, absolute value, forecast, percent error, and I add all of them together, I got 211.69, and then try to calculate average, divide by 11, because we only have 11 absolute value forecast percent error. So that give me 19.24%. Again, we convert everything to percentage. Why this one is so nice? Because it's actually tell us it's easier to interpret. It tell us what percentage of the error for forecast at that time. So as you can see in this model, if we use naive forecasting, so 19.24% is the percent error for the forecasting result. So it's just allow you to compare different kind of time series data as well. So I saw the best model that can actually achieve 4%. And of course, here we see 19.24%. We cannot see, it's kind of not as ideal. But again, MAPE and also the MAE are very popularly used. If you are using the mean square error, usually what I do is to take a positive square root called RMSE. So because it's really hard to interpret the result when this statistic is not measured in the same scale as your time series value. Okay. So after we learn different kind of metrics, I want to show you that how we are actually able to compare. If you have a multiple model, you can select from, and how do you know which model is doing better? So after we look at the naive model, I want to introduce in the second model so that we can actually see the result of my metrics and to see how can we based on the metric to select the best model. So the second model I introduced in here for time series model is called average of all past value forecast error. So when comparing different forecasts, we should select the forecasting method that fit best the historical time series data if we think that the historical pattern will continue into the future. And suppose we forecast the gasoline time series data using the average of the past values. And then thus if we use the notation y hat for the forecast at time period t, and we will have like let's say instead of just using one period, we are actually using all the historical period. So in week 2, we only have the one period ahead of it, so we write down 17. In week 3, we actually have 2 past periods, 17 and 21. So our forecasting will be 17 plus 21, finding the average, and we got 19. Okay. Now we look at period week 4. And we will have the past 3 period available, right? So we are calculating average of the past 3 period, and we also get 19. Okay, and then in week 5, and we will have 4 weeks data available. We calculate average, that gives us 20. So this is the second model we can use to do the forecast. So it's a little bit more complicated than the naive because it involves some the average or historical values. So now, based on this data, we are able to calculate the forecast error. And then after we got forecast error, we can calculate the metrics we just learned, right? So now, let's compare. Which model is better? Is that naive method or average of the past value? So the first metric we're using is MAE, mean absolute value. The second is MSE, mean squared error. The last one is MAPE, mean absolute percentage error. As I mentioned, we usually don't use the first one because the first metric we learn are not allow us to really actually see. If you look at the first method, so MFE, it doesn't count. It's usually misleading us to judging if the model is good or not. So therefore, we use MADE, MSE, or MAPE to make a decision. So the key here is we are choosing the model that has the smallest matrix value. So for instance, MAE, as you can see, the average of the past value gives us the smallest. MSE, same. MAPE, same. So all 3 models leading to the average of the past value is the better model than the naive model. Okay, keep in mind, for the accuracy metrics, the smaller, the better. So if the model gives us the smallest metrics we learn here, that means that model is better fit to predicting the time series data. Okay, great. So after we finish learning how to measure the accuracy and learn of 2 very simple forecasting model, and in next video, we're actually gonna dive into relatively more sophisticated time series forecasting model.